All right, so the first thing that we're going to do is inverse on a graph. Kind of like I just showed you with the patty paper. Okay? So here I'm given the line y equals 1/2 x plus 3, and they have so kindly drawn it for you on the graph. How nice of them, right? Now, in order to draw the inverse without first finding the inverse algebraically, what you need to first have are the points on the line. So we're going to come up with, now, am I crazy, or does your have tables and mine doesn't? Yeah. Oh well, weird. Okay, so we are going to, for f of x, I'm sorry, y, our original function, we are going to write down 4 points, and then we are going to do, what do you think, to inverse those points? Yeah, just switch the x and y. Good. So let's find 4 perfect points. Someone give me one. Now notice, so this same thing wrong happened in the first class. Are these going up by 1? No. What are they going up by? 2. So, well, give me a perfect point again. 2, 4. Yes. Give me another one. -2. Yes, 6, 6. Good. What? One more. Give me the x-axis intersection there. So it's going up by 2, so it's not -3. What is it? -6, 0. So I'm going to write these down in order. -6, 0, 2, -2, 2, 2, 4, and lastly 6, 6. So now that I have found these points, what do I do to get the inverses of these points? Yeah, you just switch the x and y. So what is the inverse of the point -6, 0, Arya? 0. You're right, -6. Good. Pariti, what about -2, 2? What is the inverse of that point?
2,
Wonderful. Ella, what is the inverse of 2, 4? Yes. And lastly, the inverse of 6, 6, Molly. Yes, it remains the same, 6, 6. So now, to finish finding the inverse, we're just going to graph these points. So I have 0, -6. It's down here. I have 2, -2. 4, 2. And 6, 6. And then I'm just going to connect these points. So if this original line was y, our new inverse line is y to the power of -1, or the inverse of y. So now, I'm going to take a guess at what the equation for that inverse would be. Yes. So I always like to first write down the y-intercept, because that's kind of like a gimme, right? The b value at the end. What is our b value here? -6, right? So that's on our end. And then we know we have an x. And what goes in front of the x always in a linear line? Slope, the m, right? Mx plus b, the m. What is our slope here? 2, right? My rise from one point to another is 4. My run is 2. 4 divided by 2 is 2. So that's my inverse function. Any questions on how we found the inverse graphically? All right. We're not really, this is showing you how you could find it graphically on your test. Are we expecting you to find the inverse graphically? No. Are we expecting you to know how to graph the inverse once you find it algebraically? Yes. And we'll practice that on the sheet you picked up later on, okay? After the notes. All right. So now we're going to do it algebraically because this is algebra. At its core, what did we say inverses are? What do you do to find an inverse? Switch the x and the y. So that's literally what you do to a function in order to find its inverse. You take y, and instead of writing y, you write x. You take x, and instead of writing x, you write y. You're switching the x's and the y's. Now sometimes, like in this first teacher example, it gives you f of x. What is f of x the same as? Y, right? So the first thing you do is switch out f of x for y. Then, because we're trying to find the inverse, we switch the places of our x and y. So x comes out front. Then we still have an equals -2. And now instead of writing x with the -2, I'm going to write y. I'm trying to go slower. It's hard for me. Okay. Now, how are functions and equations normally written? Y equals. So what do you think we need to do at this point to finish finding our inverse? Solve for y. Get y all by itself. So this is a linear equation. What do we need to do first in order to get y by itself? I need to subtract 5 from both sides. So I have x minus 5 is equal to -2y. Then what do I need to do? Divide by -2 to get it off of the y. So either you can leave this as what is called a rational function, or, and especially because you may be asked to then graph this, I would put it in slope-intercept form, mx plus b. That means that we're dividing both of these by -2. So how can I rewrite x divided by -2? I would put -1/2 x. So it's clear our slope is -1/2. And then what do I write? Plus, good, 5/2. Whoops. I started circling that, but why did I stop circling that? Yes, you need to rewrite this with our inverse notation. That's f raised to the -1 power of x is equal to -1/2 x plus 5/2. And then I am done. I have found my inverse. Any questions about this process? Okay. You guys go ahead and try to find the inverses of both 1 and 2 on this practice right here. Find the inverses. Inverse function did you get for number 1, Francesca?
The f negative 1 of x equals 1/3 x plus 3.
Yes. This is the inverse you should have gotten. Does anyone need me to do this problem?
Why is it plus 3? It should be plus 2.
6 divided by 2.
Yes.
It's 2.
Oh, okay.
It's a 2, yeah. And then, what did you guess the inverse function for number 2, Julie?
The inverse of g of x square root 1/2 x minus 3.
Good. That was our inverse function. Does anyone need me to do this one?
Yes.
Okay, so I'll do real quick. First thing is change g of x out for y, and then switch x and y. I'm just going to combine that into one step and immediately switch x in front and y for x. Then, whenever you're solving for something, which here we're trying to solve for y, we're trying to get y all by itself, you do opposite of PEMDAS, which means we deal with the values that are first added or subtracted, which there isn't anything added or subtracted here, so we skip right to multiplying and dividing. Now, we have a 2 times the set of parentheses. Am I going to distribute the 2 into the parentheses? No. Why not? You're trying to get y all by itself. If I distribute the 2 in, first of all, it's illegal math because this is squared. Second of all, you're adding stuff to the y. We're trying to get stuff away from the y. So, what do we do to get the 2 off of the parentheses? Both sides get divided by 2, and I have x over 2, or 1/2 x, however you want to write it, is equal to y plus 3 squared. How do we unsquare something?
Square root.
Yes. I, unfortunately, already today have had many people do this. What is wrong with this? Is this how squaring works? What are you doing when you're squaring?
Making y plus 3 twice.
You're multiplying whatever is being squared times itself. So we would have to FOIL or double distribute in order to deal with the square. Luckily enough for us, there's another way to get rid of the square in this circumstance. All we have to do is the opposite operation, which is square rooting. The square and the square root cancel out, and you're just left with y plus 3. What is our final step in getting the y by itself here? Subtract 3 over. And then lastly, I change y out for g of x, and I have my answer. Yes?
Did you say x over 2 is the same as 1 over 2x?
No.
No? Okay.
x over 2 is the same as 1/2 x.
Oh, okay, guys.
Okay. It's not the same as 1 over 2x. That would be taking the x and putting in the denominator, but we know that when we're multiplying a fraction times anything, you're multiplying the numerator times the anything. So it's x over 2 or 1/2 x. Those are the same. Any other questions? Okay. Down here, we have actually already done this. We did it in warm-up. What they could do is they could ask you, are two functions inverses? How would we check to see if two functions are inverses of each other? There are two ways. You can find the composition of those two functions, or you can graph them and see if they're inverses. Here, we're going to practice finding the composition. When I say composition, that means putting one function into another. Now here I know it says f of g of x is equal to g of f of x is equal to x. You only need to plug one function in. You don't need to do it twice. So that means I wouldn't need to plug f of x into g of x and also plug g of x into f of x. You only need to do one of them. And it doesn't matter what you do. So you can pick the easier one. If, when you plug it in, your end answer ends up being x, it means what? They are inverses of each other. So let's go ahead and try this one right here. I have f of x is equal to, that's x minus 4 over 3, and g of x is equal to 3x plus 4. Looking at this, which one do you think is going to make our lives easier? Plugging f of x into g of x, or plugging g of x into f of x? So let's try it. You're saying plugging g of x into f of x. So that's f of g of x. That's 3x plus 4 minus 4 all over 3. Oh, I guess it's easier. I guess it doesn't matter in this case. They're both pretty easy. Okay, we can stick with this one. I personally would have done the other way. So here, first, I combine like terms. What are my like terms? 4 and negative 4. Look what happens. They cancel, and I'm left with 3 of x over 3. What happens there? The 3's cancel, and you're left with, so f of g of x is equal to x. Meaning, are these inverses? Yes, f of x is the inverse of g of x. And yes, you do need to write some sort of yes, they are inverses statement. Any questions? Any questions there? All right. You guys try to prove that 1 and 2 are inverses. Show me that 1 and 2 are inverses. And if they are, say yes. And if they're not, then say no.